Um, a warm and pleasant good morning to one and all present here. In this fresh morning, I take a privilege to welcome you all for this webinar on blockchain technology organized by ACM under ACM Distinguished Speakers Program. I welcome our distinguished speaker, Dr. Ashwani Kumar, Professor, School of IT and Engineering, VI Vellore Institute of Technology. Welcome you, sir. I welcome our Venerable Dr. P. Deepalakshmi, Professor, Dean, School of Computing, Faculty Sponsor of Kare ACM, for being a backbone of this session. I welcome you, ma'am. I welcome all the participants from various colleges and universities. I hope this session will enlighten you with enough knowledge. And now, I request the student coordinator, Ms. Vasavi, to introduce our resource person.
Thank you, ma'am. I take this privilege of introducing our ACM distinguished speaker, Dr. C.H. Ashwani Kumar. He is a professor and former Dean of School of Information Technology, Veluru Institution of Technology, Veluru, India. I welcome you, sir. Dr. C.H. Ashwani Kumar completed bachelor's and master's degree in computer science from Acharya Nagarjuna University, India. He holds a PhD degree in computer science from VIT, India. His research interests are information security, machine learning, and quantum computing. He was a recipient of Young Scientist Fellowship from Tamil Nadu State Council for Science and Technology. Also, he was a recipient of Indian Express, India's leading English daily newspaper, Inspiring Teacher Award 40 under 40. He has executed few research projects funded by the Department of Science and Technology, Government of India, Department of Atomic Energy, Government of India, Ministry of Human Resource Development, Government of India. He published more than 100 referred research articles so far in various national and international conferences. He is the editorial board member for several international journals. He is the senior member of ACM. He has organized a 3-week summer school on information and system security in association with ACM India during May and June of 2017, which attracted students from across the country. Thank you.
Yeah. So, Madam, shall we start the session?
Sir, please proceed, sir.
Please, sir, you start the session, sir.
Okay. Thank you for the wonderful introduction and the student organizer of the ACM. And at the outset, I would like to thank the organizers of the student organizers, the faculty, and the dean of the Computer Science and Engineering Department of the KLU. And thank you very much for inviting me to this to deliver a talk on the blockchain technology. And also I appreciate the attendees of the this talk, because everybody is remotely connected, and they're all curious to participate in this blockchain technologies talk and want to learn something out of this talk. I appreciate for your curiosity and interest. And this particular program is initiated through the ACM's Distinguished Speakers Program. And I hope all of you, the student community especially, are aware of the ACM's, which is one of the largest, I can say, more authentic professional body of the computing. And I would in fact suggest all the students of computer science or information technology, or different other disciplines of computer science, to become the members of the ACM, so that you get maximum benefit out of the professional network. And in fact, if you observe, there is no Nobel Prize for computer science. The highest award in the computer science is the Turing Award. And this award is jointly given by the ACM and Turing Award, which we call it as the ACM Turing Award. And so in fact, it is the professional body which is spread over the globe, and it has about 1 lakh members, and both professionals and as well as students. And there are about 170 countries participation in that. the main motivation of the ACM, the mission is to help the computing professionals and students so that they would be executing their profession at their best in a more creative manner, and also to connect with the other peers, other professionals, and hence understand the latest development, understand from each other, learn from each other, inspire from each other. That is what is the main mission and motivation of this particular professional society. So, in fact, I'm proud to be an ACM senior member, and I'm the member from last 13 years. And in fact, I'm able to get continuous email digests about the latest research trends, industry perspectives from ACM blogs, and also I get the interviews of the various researchers across the globe about their research as a continuous mail threads. And hence, this is the opportunity which I am getting through ACM to be the one of the distinguished speaker from the in the country. And all of you are able to see the slide, right?
Yes, sir. Visible.
Yeah. Okay. So this particular program is made possible because of the ACM, and generally ACM will take care of the travel in case if the speaker has to travel to that the hosting institute. And in this time, because of the pandemic, we are unable to travel, and thanks to the technology, though we are unable to travel, we are able to connect with each other and exchange the ideas. Okay, so in this particular session, I will be covering the various aspects, introduce the blockchain, what is a blockchain technology, why it is got significance, what are its technological backgrounds, and how this technology is evolved, where to use this technology, when to use this technology, and how actually this technology will benefit us, especially we the people, how the people will ultimately get benefit out of it. So, in fact, I can say that blockchain technology has, in the recent past, has revolutionized several things. The way industry works, the way governments works, the way the businesses works. There is so much of fascination about this technology, and there are so many jobs coming out of this technology. There are a lot of the hype behind this technology. I will give you one simple example to begin with, and then we will proceed and try to understand this particular technology further. So all of us are familiar with land or property purchases and all that, how they happen. So imagine somebody wants to buy a land or somebody wants to sell a land. We all know what is the general process, and we all know what are the difficulties involved in that. Though somebody wants to buy a land, people will always think once and twice whether the property documents, who is selling this particular property, is the documents are correct or not, or else is this particular sale, or else these transactions would be perfectly recorded or not. By chance, the seller will be selling to multiple parties. There are so many disputes like this, especially in the metros where the land value is very high. And similarly, and we do not know sometimes who is the true owner of the property. Sometimes, not sometimes, majority of the times there are so many disputes coming out of a particular transaction, and it goes to the courts, and people will be wasting a lot of money and time, especially in buying land or real estate property and all that. Is it not that we have experienced, or we have heard, or we have read about these things in the news? I hope all of you must have read these things in the news. Now I just wanted to understand how you guys are actually viewing this particular this one. So I request madam to just share the first form with all of the participants, and I request all the participants to share your thoughts about how actually you are feeling about the technology, and please share your inputs. Madam, can you please share that Google form with all the participants?
Yes, sir.
So all of you, please, it takes only 5 questions, and all those 5 questions are important, to understand your understanding of the technology, whether already whether you are familiar with. It just takes a minute, not more than that. All of you, please participate in this poll or the survey, so that we will be able to understand better our students or participants. So I want to see, I'm just seeing the responses also side by side here. I want everyone, all the participants, to participate in this survey. Okay, it is good that about half of the participants have undergone the security or cryptography course, but yeah, it's good that see, I think a lot of students are participating through the mobile device, in the sense a cell phone or a mobile phone. Okay, 17 responses. Okay, I think all of you have participated in the webinar so far. Okay, I want to see the responses. You want to understand blockchain technology from this webinar. You want to gain knowledge. Knowledge on what? So please be precise. Blockchain, into blockchain, basics of blockchain technology. Okay, I will satisfy my needs in blockchain technology, to get aware of the blockchain technology, more know about it. Yeah, so I think please keep doing the poll, and recording. Please keep recording your responses, and so we will continue the discussion. Yeah, I have given you one scenario. The scenario is that people wants to make the transaction for the land property or a real estate property. People have to be very, very cautious while doing this particular transaction. The reason is that there are a lot of disputes involved in that. Nobody knows whether the seller is selling to multiple people, whether the documents related to the property are perfect or not, because anything may be tampered. Is it not? Anything may be tampered, or the property documents may be tampered. Mutamil Sundar, Mutamil Sundar.
Is
Are
there
you able
any
to?
assistance you need, sir?
No. I just wanted to understand. I just wanted to interact with the participants.
Sir, interaction with the participants is possible only through the chat box.
Okay. Right, madam. Understand.
They can ask questions in the chat box. I ask the students to raise the questions. You carry on, sir. They will do slowly.
Sure. Okay, no problem. So the point is, we wanted to understand if there are certain disputes while making the transactions in the land purchases, real estate property, and all that. The disputes comes because the land records or property records are easily tamperable. Somebody can go to the somebody can go and then tamper the documentary evidence. Somebody can do some kind of a bribing in the registry office and then tamper the records. These are all possible. So imagine you are having a technology. Imagine you are having a technology in which you record everything. You record everything, every transaction, every property details of the individuals, whose property, this particular property belongs to whom, a particular flat or a particular plot, a particular farmland or a particular garden or particular real estate property belongs to whom? Who is the real owner of the property? Or who are the other litigants of that particular property? Similarly, when this property was sold to whom? And what are the boundaries of this property? Like this, all the information, imagine, generally this information would be available in the registrar office and also in the documents. But these resources are easily tamperable. That is where the issue comes. Imagine we are having a technology wherein which these documents, these details are recorded in a system, and that particular system or else a database is available at multiple places, not in a particular single server. It is available in multiple places, and the recorded transactions are not tamperable. Somebody cannot tamper these transactions. Somebody can easily verify who has the property details and all that. So such technology is nothing but the blockchain technology. It is called blockchain technology. The reason is block, because a block is generally will have lot of transactions. You pool several transactions, keep all those transactions in a block. That is called block. And several of these blocks are actually interconnected and hence forms a chain. That is why you are calling blockchain. Such chains, if you remember, all of you have seen the cycle chain, right? If you seen the cycle chain in which that iron spindles are interconnected, so one is linked with the other, so it forms a chain. Similarly, you remember in your data structures the linked list, doubly linked list. Okay, doubly linked list, what happens? That is a data structure wherein which you have a pointer to the next list and also a pointer to the previous list. So in fact, blockchain follows similar structure. So you collect several transactions, record them in the block, and there are multiple blocks. All these blocks are interconnected. So you can go from one block to the other block. Either you can move in a forward direction or else you can move in the backward direction. And the transactions once recorded in that particular block are not tamperable. You cannot tamper the records. So such technology is called blockchain technology. And another beauty of this technology is it is unlike your client server technology, wherein which you store the data in a single database in a particular server. That the blockchain is available in multiple nodes. Means what? It is replicated. So it's not that there is a single node in which you are maintaining the chain, multiple nodes maintain the chain. So that means, like, nowadays we are having core banking system. Means, you can go to any ATM and you can withdraw money from anywhere. The reason is all the ATMs are centrally connected, and whenever you want to withdraw money, your account is verified, balance is there, then you are able to withdraw the money. Earlier days, when this core banking system was not there, if you want to withdraw the money, you have to go to the bank branch wherein which you are having the account. Imagine you are having the account in your campus branch. Imagine you are having an Indian bank in your campus branch. If you want to withdraw the money, you should go only to that particular bank, because that particular branch only maintains your account, and your account details are in the ledger of that particular bank. And hence, if you want to withdraw the money, that particular branch people will verify in their ledger and see if you are having enough money in the account. Only that money they will allow you to withdraw. Now that difficulty has gone. Why? Because all the Indian bank, what they have done, they have created a centralized server. Imagine Chennai is the headquarter. So imagine that they have a data center in Chennai. They will have a centralized server. So all the accounts they can maintain, and hence you can go to anywhere in the ATM and anywhere you can withdraw the money. Well, has the technology stopped there? No. After that, what they have done, they have even combined the several banks. Means nowadays you can go to the HDFC bank and use your Indian bank ATM and withdraw the money. So that means there is a lot of interconnection that is happened. So now that means there are transactions that are getting recorded. Now these transactions are recorded in a particular block, and once the transactions are recorded in a block, the blocks are connected with each other. And also the transactions, once you make the transaction, you cannot tamper. So that is the technology called blockchain technology. Let us go further and understand. So are you able to see this next slide?
Not yet, sir.
You are not able to see this slide, madam?
Yes, sir, it is not visible now.
Oh, one minute.
You need to use the share option, sir, individually for every screen.
Yeah, are you now able to see?
Visible, sir, visible.
Yes, yes.
So if you understand the evaluation, if you want to try to understand the evaluation of computing or certain milestones in the computing, 1970s you have the mainframes, and then 80s you have the personal computers, and in 1990s, in fact, one of the most scientific revolution of the world, internet has come. Internet has connected everybody. And then in 2000, on top of internet, you have social media and the mobile computing. Now the next revolution is the blockchain technology. Okay, so how the blockchain technology has come? Of course, it has not come for the purpose what we discussed. It has come for a different purpose. It has come for a purpose called cryptocurrencies. Okay, so the purpose that with which this particular technology has come is different, but the people realized the potential of this technology and started using this in different applications. Okay, so all of you are aware of the explosion in the growth of data everywhere. Okay, because of connected devices, because of the internet, lot of data is getting accumulated, lots and lots of data, which we are all aware of it. Okay, and you can see the statistics on how many posts you will be seeing in the YouTube videos, how many the Facebook likes, dislikes. It's a lot of stuff going on in the data. But the point is that there are so many issues when you want to really understand and derive meaning out of the data, type of data and all that, knowing how to structure the data and all that. But the most important point in the today lectures context is the necessary infrastructure to deal with the data and secure the data. How you can handle it? Imagine your traditional banking system to online banking system we have gone. Now the point is how we can make our transactions secure. Similarly, from our land records, the traditional land records of papers and documents, people have gone to the system server or network based computers where in which to store the your land records. But now the data has moved from physical documents to the digital documents. How you can secure that particular data? So your land records data, or else your banking transactions, in the financial transactions, or even the healthcare data, or your supply chain data. So there is a lot of data that is coming out online or internet, or your networked transactions. The point is that there are so many issues with that data with regard to the way you use it, the way you structure it, the way you derive meaning out of it, the way you apply data mining of that. All that are different researches. But in the today lectures context, the point is that how you are going to secure this particular data. Now let us understand what is a blockchain. You need to understand the terminology very clearly. Blockchain is an immutable digital ledger. What do you mean by ledger? You can think of ledger as the database. Imagine you go to the bank maintains the ledger, means the account details. Imagine X, name X, has this particular account, and in this particular account this much is the balance available. Now somebody, if imagine X goes to the bank, he wants to either add the money or withdraw the money. Then what the bank will do? Bank will verify with the ledger. Ledger has the account number one. Account has some money in that. then he wants to withdraw, and whatever the withdraw money, imagine in the account he has 10,000 rupees, he wants to withdraw the 5,000, bank will allow. Imagine it, he has 10,000, if the bank, if he wants to withdraw 15,000, and they will say no. All this verification happens with the ledger. So the ledger you can think of as a database. So blockchain is an immutable ledger. Why you are saying it is an immutable? Immutable means you cannot tamper that. Imagine if you are maintaining the ledger in a book, somebody can easily remove that for one particular page of that book, or else somebody can strike off something and write something else. Somebody says that, I have 10,000 rupees, and if someone can go and then tamper that record by removing with pen on that book, it is possible. So book is not an immutable, but you want to create an immutable ledger, which is a digital ledger, and implemented in a distributed fashion. What do you mean by that? It is distributed. Ledger is not stored in a single place. It is distributed across multiple nodes. That is called the blockchain. So it's an immutable digital ledger implemented in a distributed fashion, and there is no central authority for the blockchain. That is another beauty of it. Imagine you are having a client server architecture. What is the fundamental problem or drawback of the client server architecture? Imagine your server goes down, your entire services goes down. What are all associated with the server? So that is the key problem of the central authority. Now the point with this distributed fashion is, even though if one node goes down, still you will get the data from the other node because it is distributed. Okay, so you need to define the blockchain as an immutable distributed digital ledger. That's what is the point. Okay, so it is essentially a distributed database, and it is tamper free. You cannot tamper it, and it is distributed. Okay, and there is no central authority for that. And people have realized across the globe the impact of the blockchain technology, and then they started using it for different applications. Now, especially they have majority of the governments have legalized the blockchain. Most of the countries is the Western world, Europe, US, and of course even in India, majority of the state governments are adopting now the blockchain technology for their own databases or for their own ledgers. So blockchains are distributed ledgers, number one, this which we have already discussed. And essentially, I have already said, fundamental unit of the blockchain is a block. Okay, block is nothing but it is a group of transactions. There are, suppose, 10 transactions. All these transactions we can group them, keep them in the block, and these blocks are interconnected. And I said these blocks are not tamperable, means they are tamper proof. You cannot tamper them. How you cannot tamper them? Because they are cryptographically signed. Okay, they are cryptographically signed. Signed means, even if suppose somebody gives you a what is that, a paper, asks you a signature, you will sign. And if you sign, somebody can see that and then practice that signature, and then they will also sign like you. But the point here is that it is cryptographically signed. What do you mean by cryptographically signed? We will discuss that later. But I have expanded the definition of blockchain technology. Now, blockchain is a distributed digital ledger which is cryptographically signed blocks. Okay, so that is the now expanded definition. Now, each block, as I've said, each block of transactions are cryptographically signed. When you can sign that, only if there is a validation. Means what? Can every transaction will go to the block? No, it cannot happen. Only if the transaction is valid, only it goes to the block. Means what? Number one, you are verifying whether the transaction is correct or not. Who is verifying? Nodes in the network, not one individual. If it is only one individual, then there is a chance that he will be malicious. But all the nodes in the network will verify every transaction. If all the nodes in the network agree to the transaction, then only it goes to the block. And this block gets cryptographically signed. Means what? Imagine there are 10 friends, 10 students or 10 friends. 10 friends are like 10 nodes. A transaction between A to B would be known to all other friends in the network. These 10 students are 10, there are 10 friends in a network. Each friend is like a node. Now imagine there is a transaction between one friend to the other friend. This transaction would be known to everybody. If everyone says that yes, this transaction is correct, then this transaction will be pushed to a block. After say a couple of transactions, say 10 transactions, you will create a block. Now that block would be cryptographically signed. That block would be linked to the other block. Hope you are able to understand. Number one, a transaction is not closed transaction, like it is an open transaction. Everybody can see the transaction, what is happening. Number one, if some transaction between A and B happens, if there are 10 friends in the network, 10 nodes in the network, everybody knows that there is a transaction between A and B. Okay, so that is what is the validation. And if every node agrees to the transaction, then only you will be able to create the block. And that agreeing is called consensus. There are algorithms for that. Okay, so once you create a block, you cannot tamper the block or you cannot change the block. Okay, you cannot change the transaction. And another thing, each block is replicated across the copies. Means what? All the nodes in the network will have the same database. So it's not that this ledger is stored in one particular node, it is stored across all the nodes. So far, do you have any doubts? We will pause here. I'll ask, do you have any questions? Okay, Elil says, sir, send PPT. Mohasin says, sir, if block is distributed at different location, who has control over the block? Mohasin, there is no control over the block. Sorry, there is no single point control. As I've said, imagine you have 10 nodes in the network. If there is a transaction between two entities or two parties, if the transaction is valid, means all the nodes should say that that is a valid transaction. If the transaction is valid, that transaction will be entering into the block. Then if say such 10 such transactions are entered into a block, that block will be created and it would be cryptographically signed, and that same block will be added to the previous blocks, and this updation would be reflected in the all the nodes. Hope you are able to understand. Okay, so okay, so I think that's all the questions. So okay, Mohasin able to understand. Okay, fine, thank you. So we will continue. So now you are able to understand. The beauty of the technology is that number one, there is no single authority. There is nothing like a client server. If you have 10 nodes, all the 10 nodes will maintain this particular ledger. If there is a new transaction, the new transaction would be verified by all the nodes. If all the nodes agrees to the transaction, that would be added to a block. And once a new block is created, that block would be added to the chain, and the chain would be updated in all the nodes. Okay, that is what is the blockchain technology. Now the blockchains are nothing but is a part of your databases, your distributed databases, distributed ledgers. So it's a part of that. You can find there are two varieties of blockchains called permission blockchain and permissionless blockchain that we will see in the upcoming slides. So now let us see a simple diagrammatic representation of the blockchain technology. Now imagine that how this particular technology works. Imagine that somebody wants to request a transaction. Somebody wants to make a transaction. Now what will happen is this transaction would be informed to all the nodes in the network. Now you see there are node 1, node 2, node 3, node 4. Okay. So the requested transaction is informed to all the nodes in the network. Remember, all the nodes in the network will be maintaining the blockchain, the same blockchain. Then what happens? It is like this. Imagine there are four students. All four students are having a notebook. Okay, all the four students are having a notebook. Imagine there is a new concept to be written. It will be informed to all the four students. All the four students should listen to that concept. They should write in their notebook the same concept. It is like this. Okay, so when once the requested transaction is agreed by all the nodes in the network, then that particular transaction would be entering into a block. And once you have 10 such transactions, 10 or 15 or whatever is the number, once that block is full, that block would be added to the chain, and the chain would be updated in all the nodes. Okay, so that's what is the validation, wherein which the network of nodes validates the transaction and the user status using the known algorithms. And once the verified transaction, if there is any cryptocurrency or contracts, records, all such verified transaction happens, once that transaction is verified, it will be added to the block. Once it is added to the block, all the nodes in the, so you are completing the transaction and the block is added. Once that block is added, that will be reflected in all the nodes in the network. So where this technology is applied, the main benefit of the technology is, number one, since all the nodes in the network have same database, number one, you have increased the transparency. Everybody knows who is having what. Now somebody says that I have 10,000 rupees, even that is known to everybody. Somebody says that I have transferred this much money to somebody, even that would be visible. Okay, so number one. Number two, accurate tracking. Number two, permanent ledger. Somebody cannot say that I have deleted it. Similarly, since all this is happening, you are able to reduce the cost. Okay, but the point is that there are some certain unknowns in this. The technology is a little bit complex. Okay, in the sense that when you are maintaining the cryptographically signed nodes, or when you are maintaining that tamper proof blocks, technology is little complex. Where all this can be applied? In the automotive sector, financial sector, voting. Why in voting? Because voting, what is very, very important, if suppose I vote for somebody, somebody should not tamper. Imagine if I vote for some party X, my voting machine or somebody should not tamper that and vote it to some other party. So since it is an immutable technology, for voting purposes, blockchain technology is widely used nowadays. And especially there are certain countries now who are depending on the e-voting. They are using the blockchain technology. And even now our election commission, they are trying to use the blockchain technology for our election purpose. Not only that, imagine a university issues a certificate, degree certificate to the student. Now, if the degree certificate is recorded in a blockchain technology, means somebody cannot tamper the certificate, somebody can easily verify that certificate, and it is a potential application. Now, one of the IIT has taken up the project to take the blockchain technology for issuing the digital certificates of the universities. The healthcare, wherein which patients' data, patients' information to be kept, number one, confidential. Number two, these health records are not tampered. So like this, there are n number of applications. So if you see the network architecture, essentially it uses your internet. Okay, essentially your internet is the your backbone platform, backbone network. When I say nodes, all these nodes, node 1, node 2, node 3, nodes can be in your typical local area network, or nodes may be there across the globe. But the point is that node A, node B, node C, all these things are connected via your internet. Okay, the TCP, using TCP/IP protocol. Okay, but on top of their application, they are using the blockchain network. Okay, there are several applications like Ethereum, Corada, like that. There are so many applications which are blockchain based applications which you can run at the application layer, but the nodes are actually connected through internet. Okay, this is the typical overview of the blockchain network architecture. Okay, so these are all the applications: supply chain, fintech, shipping, mining, healthcare, and there are so many companies now: Facebook, Google, Ford, Apple, all the major giants, all the companies, they are using the blockchain technology. And hence, what I suggest to all the students is to know about the technology, to understand where it, to understand the platform. Madam, I think can we ask the participants to mute?
Sir, actually, the participants' mic is not in on state, sir. Only you, me, Deeplakshmi ma'am can
Fine.
speak.
No problem. Yeah, no issue. Okay, so these are all the potential applications. But as I've said, if you see the technology is appearing to be complex. But you need to divide the technology. When I say divide the technology, which technology you use it for what purpose, and understand the technology, then you will be able to understand what is blockchain in a very clear fashion. Especially you are a computer science student, you should be able to understand quickly. So blockchains use core computer science concept. What is core computer science concept? Number one, your database. Number two, your data structures. Number three, your networks. Number four, security. Okay, these are the things which essentially backbone of blockchain technology. And of course, you are going to use some of the financial concepts like the ledgers, transactions, all those things. But essentially, fundamentally, these are the backbones of blockchain technology. So in security, I'm not going to touch about your linked list or networks and all that. But in the security, you are having certain things like hashing approaches, because when you say the nodes are connected, number one, how they are connected. Number two, they are digitally signed. How they are signed? Using the cryptographic primitives. First primitive is the hashing approach in the security. Essentially, what is a hashing approach? Of course, in the interest of time, I will give you with an example and I will proceed. Imagine you are giving username password for your email. Username is known to everybody, but password is known only to you. That means even the web server, mail server should not remember, should not record actual password. But if it don't record the password, then how it will verify? What it will do is, it will take your password. That means whatever the password you are entering. Imagine you are entering a password called ABC123. So one should not use such type of simple passwords. But for illustration purpose, I am saying your password is ABC123. Then what the web server would do is, a web server will create a hash of that and store this hash of your password in its database. So whenever you enter your username and followed by your password, the server is actually verifying hash of your password with the hash that is already stored. It will not do your simple matching of the password whatever you have entered, because even the server should not know what is the password you have entered. And hence, it will store only the hash of it. Then what is meant by this hash? Hash is a one-way function. Mathematically, hash is a one-way function. What it will do is, it's a one-way function which takes variable length input and produces fixed length output. Okay, so essentially you can enter any length input, but the output of that hash function is fixed. So it will take that. So you enter, say, ABC123, and then it takes the hash of it. Beauty of this particular function is, you can do only one way. Means you can enter the plain text and get the hash. But reverse is not possible. Means you take the hash, getting the plain text. So that is the beauty of the hashing techniques. There are so many hashing techniques which are called SHA algorithms, the message digest and all that. So the blockchains uses the secure hash algorithms called SHA algorithms. So hash algorithms are one-way functions, and they are all collision resistance. Collision resistance means no two hashes will be, no two plain text will be having the same hash. That is what is collision resistant. Okay, there are so many things like that in the those so many principles behind the hash. So what it will do is it will take the variable length input, produces fixed length output, and you can reverse is not possible. So I have given you a particular example here. The slide shows example, and of course, those who have already studied cryptography and network security or studying cryptography, they will be able to understand quickly the hashes. Otherwise, those students who have not studied the hashing approaches think that number one, it is a one-way function. Number two, it takes a variable length input and produces a fixed length output, and you cannot calculate the reverse. Means one way, it's only one way. You cannot take hash and get a plain text back. And the second cryptographic primitive that is used in the blockchain technology is your asymmetric key technology. In cryptography, there are two types of algorithms. One is symmetric key algorithms, other one is the asymmetric key algorithms. Symmetric key algorithms, what they do is you perform encryption with one key, and you can perform the decryption as also with the same key. It is like your room lock. You will be using the same key for locking purpose and the same key for unlocking purpose. Okay, but in the cryptography there are other algorithms called asymmetric algorithms, in which you use encryption with one key and decryption with another key. So such type of techniques are called asymmetric key techniques. So essentially, this is the beauty. This is the example that shows. Imagine Bob wants to send some message to Alice. So what Bob would do? Bob would take public key of Alice and encrypt the message and send it to Alice. What Alice would do? Alice would take that message and decrypt it with its private key. So even if somebody listens to this communication, they cannot break this encryption because the private key is known only to Alice. Okay, so that is what is asymmetric key algorithm. So asymmetric key technology is used in the blockchain purpose. So here what happened is, I've said you have two keys. One key is called private key, another key is called public key. Essentially, private key is used for digitally sign the transactions. Since you sign the transaction with the private key, people will verify the transaction with the public key, because your public key is known to everybody. You signed with your private key, and the transaction is verified by your public key. So that is why your asymmetric key technology is used in the blockchain. So you are using hashing techniques, you are using asymmetric key techniques in the blockchain. Now, what is a transaction? I kept on saying transaction and all that. What is a transaction? Essentially, transaction is a kind of any operation that you perform, like transfer of assets or a communication that happens between two communicating parties. Okay, so you can see a simple example here. In fact, imagine that there is an account A, and you want to make some kind of a transfer of amount to someone else. So to account B and account C. Okay, there is some amount that is transferred. So this is the total amount that is transferred. So this is a kind of a transaction which would be recorded, and then that would be having a transaction ID. Okay, so each block in a blockchain contains multiple transactions. This also I have said. It's not that one block will be for one transaction. Each block will have multiple transactions. How many transactions? It depends upon your chain. You may say, okay, my block can have 10 transactions. My chain can have 5 transactions. You can limit that. Okay, so determining the validity of the transaction is very important. Remember, I have told already that the nodes in the network should validate the transaction. Okay, and simply somebody says that no, I have transferred money, doesn't mean that transaction is complete. Every node in the network should agree to the transactions, and the transactions are signed. When I say signed, what key is used? The private key is used, and it is verified by any node. How? The public key of the signed node would be used to verify the transaction. Okay, so and hence this gives the number one, security in terms of immutability, number two, in terms of integrity, number three, in terms of verifying the accuracy. Okay. Now, what is meant by ledger? So essentially, ledger is nothing but the collection of transactions. Okay. And so you have, I said, a ledger would be having, the details of the. It is like a large database. Okay. And as I've told, bank will. Why you are going to the bank? Because you are trusting the bank, and the bank wants that particular ledger, and it records all the transactions. Okay. And when I said trusted third party, it is like a bank, or you are recording your land property details with a registrar of the government. So, our tahsildar means what? The tahsildar is the trusted third party. Okay. But centralized ledger have many shortcomings, which I have already discussed. Okay. It is very easily tamperable. You may be losing it at any time, and it is sometimes you may enter the invalid transactions. All these are all possible with the centralized ledgers. A ledger implemented using the blockchain can mitigate these issues through the use of distributed consensus mechanism. What is this consensus mechanism? Nodes should agree to the transactions. That is what is the consensus. Now imagine that there is a network like this. There are multiple nodes here. Node 1, node 2, node 3, node 4. Every node, if you observe closely, is maintaining the ledger. How many transactions are there? Transaction 1, 2, 3. If you closely observe, every node has the same transactions. Transaction 1, 2, 3, 1, 2, 3, 1, 2, 3 everywhere. Now you are able to understand. Number one, there are 4 nodes in the network. All 4 nodes are connected. Every node has a ledger. You can think it as a database, and the database or the ledger contains same transactions. Transaction 1, 2, 3. Now imagine the new transaction comes at a particular node called transaction 4. Okay, one particular gets a new transaction saying that I want to buy this particular property, or we have made this property deal, or we have made this particular transaction. Into transaction 4 has come. Now then what will happen? This will be broadcasted to all the nodes in the network. Okay, transaction 4 is broadcasted to all the nodes in the network. Who broadcasted it? The node which received that particular transaction has broadcasted that to all the nodes in the network. Then what happens? All the nodes in the network would agree to the transaction, verify if the transaction is valid or not. If so, they will be updating the transaction in their own ledger. So that's how it happens. Okay. Now the point is that sometimes when a particular node, if you see here in this case, one particular node is keeping that particular transaction in pending. Okay, so that means this particular blockchain of this particular node is not updated. Okay, so imagine that there is a pending transaction here. Okay, so then you will be having a fork. We will see there is a conflict that arises. How these conflicts would be, again, the conflicts should be resolved through consensus. Until and unless there is a consensus, number one, consensus means nodes should agree to the transaction. Once the transaction is agreed, sometimes what happens, depending on your network architecture, one node which receives the transaction will verify that particular transaction on behalf of all the nodes and says that, look, I have verified the transaction, and then add it to the block. Now then what happens? And it creates the block. Means it is taking the load. It is taking the load of doing a particular job. In such case, what happens is that particular node will have some kind of a extra credits or coins, which people will say that rewards. Okay, so there are multiple kinds of networks involved. So essentially, fundamental principle is to have all nodes to verify. But sometimes you can even bring the role of trust and have kind of an environment wherein which one of the node will verify the transactions, and then it will create the block. That is also possible. So transactions are added to the blockchain when a particular node publishes the block. What is that node? You will call that as a mining node, because you are actually verifying the transactions, validating the transactions. All this is called mining of the transactions, and that node is called mining node. Okay. So validity is ensured by checking that whether this particular transaction is valid or not. Once it is valid, means that particular block is verified, first of all signed by the particular node which is creating the block, and it can be verified by any other node. Okay. So the other mining nodes will check the validity of all the transactions in a published block, and they will not accept a block if it contains any invalid transactions. So I hope you are able to follow what we will do to verify your understanding on so far whatever is discussed. I request madam to post the second survey, madam.
Yes, sir, I'm posting, sir.
I just wanted to see whether you are able to follow or not. So this is remember the second form is kind of a marks. You will be having a marks also. You can see what is your level of understanding. There are only 5 questions. If you answer all 5 questions correct, you will be getting 5 marks. So please, it's a quiz. It's a graded quiz. You can see the questions. I want all of you to participate so that to check what is your level of understanding, because it's almost about more than half an hour of our interaction. Okay, very good. Somebody has answered all correct. Okay, first response with all correct. These are all simple questions.
Sir, actually, I have answered. This is Deepalakshmi here.
Okay, madam. Yeah.
I tried my level of understanding. So, sir, till the people enter the feedback, you can see some of the questions in the chat box.
Yes. I will see that.
You probably could address those questions also.
Okay. When do you think Bitcoin would be adopted worldwide like normal currency? Aravind has asked the question. When do you think Bitcoin would be adopted? See, the point with the Bitcoin is like this. See, essentially, like now when the country has introduced this ban on the larger notes, the 2 years, 3 years back, people started using the digital money like Amazon Pay, Google Pay, Paytm, and all that. So earlier there were no such these things. Maybe there will be a day coming the governments start adopting Bitcoin, but so far Bitcoin in a very few countries it is legalized. In majority countries it is not legalized. The reason is that the major worry for the governments is Bitcoin is using blockchain technology. Number one, the blockchain and Bitcoins are following certain principles wherein which, while your transaction verification is open, it says transaction happened, but it actually hide who has made this transaction. Okay, if you want, you can use the blockchain technology customized in such a way that it is very difficult for the governments to track the transactions. They may know that there is a transaction, but who made this transaction? It is very difficult to recognize. The reason is in the blockchain technology, in the bitcoins, you are using a concept called digital wallets. Digital wallets are like it is like this. If I am giving you some 100 rupees, like the question is asked by Arvind. So Ashwani Kumar is giving 100 rupees to Arvind. This is the transaction. But what happens is, peripherally, it is Ashwani Kumar giving 100 rupees to Arvind. But when it comes to the record of the transaction, it is like my digital wallet is transferring money of 100 rupees to Aravind digital wallet. Remember one thing, with this public key cryptography, you can change your keys. Means when I am transferring my money to your account, I am using your public this one. Tomorrow you can, once my transfer is done, you can change that. Means what happened is people are using this facility for kind of malicious transactions. Terrorist organizations, cyber criminals, they are using this particular concept for that particular purpose. So governments are just considering that particular angle to see that that is technology is not used for the malicious purpose, and that's the reason why it is in the this one. But future, once these issues are addressed, I think it will be this one. Okay, so I hope Arvind is able to understand this one. If a and Sai Tej Verma, if a fake block is created and pushed into the chain, what happens? Remember, as I've said, a fake block cannot be entering into the chain. The reason is that if who will push the block into the chain? A node. Number one, the nodes cannot do such activity. The reason is one particular node cannot create the chain. When once a block is created, all other nodes are also verifying that particular block. Now imagine if I push the block into the chain, the same chain should be reflected everywhere. All the nodes should have that same chain. But when the other nodes verify this block and then notice that this particular block is a malicious block, then they will not update their chain. If until and unless all the nodes are having the same chain, means you don't have you cannot perform the next block's creation, so it gets halted. So there is a kind of a forking problem, and hence essentially you cannot have the concept of publishing the fake block by a particular node. Okay, and so Mohasin is asking if block is distributed at different location, who has control? I think I have answered this. Okay, so let me see how many have responded. 41 students. Okay, it's good. I think the average is about 3 and above, so that's good. People are able to answer. Which one there? I think yeah, third question, majority of you are able to answer, but still, I think about 31% are not able to answer the third question. Okay. Okay, I think 3.1 is a good number. Maybe it means you're able to follow the slides and the lecture. I'm happy about it. Good, good. Thank you very much for your attentive listening. It means that you are not just actually kept your phone on and then doing your own other activity or something like that. Thank you very much. Okay, so let us continue our discussion. So as I've said, the mining nodes will be creating the mining node will create the block, and other nodes will check the validity of the transactions in the published block, and they will not accept a block if it contains any invalid transactions. I think one of the question was also asked is whether you will be having a block with invalid transactions or else a falsified block. No, it is not possible. Okay, so and then now the beauty comes, another beauty. After creation, each block is hashed. Hope you are able to understand what is meant by hashing. So it is like a one-way function. So it's not actually the typical block. You are actually creating a hash of the entire block. Okay, so thereby creating a message digest, and you cannot tamper that. The point is, if anybody, once a block is created, and if suppose anybody wants to change any transaction once the block is done, then what happens? Number one, you have created a block with transactions and a hash is created. Once hash is created, if a transaction is changed, means your hash goes invalid. But when once hash is created and reflected everywhere, if you change the block, means your hash becomes invalid. That's the beauty of the hashing approach. So this is how uh, your blockchain block contains. So if you see the diagram, it's a block has a block header, and it has the first component called hash, which hash to the previous block. That means you are pointing hash of the previous block, means you are actually pointing to the previous block. And then the timestamp when this particular block is created, and then a nonce is a single value which is used typically during creation of the block. It is like a random number. Okay, we will see that little later, what is a nonce purpose and all that. Then after that, Merkle root hash. Okay, it is a tree structure. What is the tree, that we will see later. And then hash of the block, the current block, and then the transactions list. Okay, this is what is your block. Now this particular GIF image shows whenever a new block is created, that would be added to the existing chain, and this chain should be there in the all the nodes. That is what is the blockchain. So essentially every block would be represented like this: block header, hash to the previous, link to the previous block hash, then the timestamp, nonce, and all that. Now you need to understand what is this Merkle root hash. What happened here is that, as I've said, every block has a structure called Merkle root hash. What happens is, instead of storing the hash of every transaction, remember, you are not storing hash of every transaction. Rather, what you are doing, you are creating the hash of the block. And how you are doing that? Through a data structure called Merkle tree. What is a Merkle tree? A Merkle tree combines the hash values of data together until there is a singular root. Okay, what do you mean by that? Let us see this. Imagine you are having 10 transactions, or in this case, you imagine you are having 4 transactions: transaction 0, transaction 1, transaction 2, and transaction 3. Then what is the tree will do is, first let us take transaction 0, create the hash of it called h0. Similarly, transaction 1, create the hash of it h1. Now then you combine hash naught, that means h0, and hash 1, combine them and create the hash of both of them. Okay, similarly, data 2, transaction 2, create the hash of it. Transaction 3, create the hash of it. Then combine hash naught, hash 1, and create a new hash called h4. Similarly, h2 and h3 and combine to create the hash called h5. Then h4 and h5 are combined to create a root hash. This is called Merkle root, Merkle tree structure. Now what is the block contains? Block contains this particular root hash. Okay, means what? It is like, you created a hash of a single transaction, that is combined with the next transaction, created a new hash, and third transaction, fourth transactions combined to create the new hashes. Like that, they are all, keeping one hash, you cannot go back. Okay, that is the beauty of the hashing principle, which is a fundamental cryptographic primitive. Okay, so your data block contains Merkle root hash. So Merkle root hash of all the transactions. And remember one thing, your actual transactions are also happening. Means, imagine somebody changed this particular transaction, say transaction 1 here, means you are changing the hash. Means this has to be changed. Means this has to be changed. Now you think of complexity. It's not just like that possible. Whereas in the case of go to the land record registrar, you bribe somebody, says that this property can be modified like this. Imagine you are having transactions on a book. It is possible. You can create the fake document. But the point here is that it is impossible. Once you record the transaction, it is done. Okay, so that is the beauty of the blockchain. So now you see the chain structure. There is a block 1 here, connected to the previous. This is the root hash. Means imagine you are started in the beginning, there are no blocks, hence you call it as a root hash. Root hash is pointing to the first block, and first block contains this structure. Now it is pointing to the second block, to the third block, like that. Now here you are having the block header hash of the previous, and then timestamp, the nonce. I will be talking about nonce later, but now Merkle root hash, transactions list. Now what is Merkle root hash? You take the transactions, create the hashes of each transactions, combining them till you come to a reach to the root level. That root would be stored here. Now imagine there is a changes in the transactions. You cannot if suppose somebody tries to tamper these transactions, they may tamper, but you cannot tamper the hash, and hence verification is very easy. Okay, that is what is the beauty of the Merkle tree. So blocks are chained together through each block containing the hash of the previous block. So this is what is thing happens. So this is another illustration wherein which you see here at block naught. Imagine node C has say 200 rupees or something like that, and there is node A, node B, and they have 000. And then imagine at next block, imagine you are having a transaction wherein which C is sending money A to A with 100 rupees, and C is also transferring money to B. There are two transactions recorded here. Then what happens? You are creating hash of this. This is you need to consider it as the Merkle root hash. Then you see actually the transactions updating here, and you can also imagine all the nodes would be verifying it, whether actually C has ability to transfer this money of 100 to 100, both of them, because C has 200 rupees. Now imagine in the typical case of regular cases, what happens? C says I have sent to 100 to A, and if it is not updated, everybody thinks C is still having 200, and if C says that I have sent 200 to B or say another node, they can believe. But in this case, such type of double spending is avoided. Okay, the people call it the double spending problem. That problem is also mitigated in the blockchain. Okay, so now you see how the transactions would be piled up and then creating the chain data structure. And blockchains are maintained through the consensus of a set of computers. Means like you are having this particular nodes, the nodes should agree to the verifications, the transactions, then only it is possible. And there is no central authority. If you see the data, the network architecture here, what is the? It's a peer-to-peer network. Okay, it's not a centralized authority. There is no central authority. Okay, and each node maintains the copy of the chain, and hence you are bringing the transparency. Okay, and invalid blocks will be, somebody has asked this question, invalid blocks will be detected and rejected because it is difficult to compute a valid block. And now you need to understand what do you mean by difficult to compute a valid block. Okay, let us see that in the upcoming slides. So this is the finalized block which we have discussed. Okay, now the point is that now the consensus. What do you mean by consensus? We said when you want to add a block, node should understand, node should come to the conclusion. On what basis? Now we said a node can create a block. Okay, when can it create a block? Is it that I can just simply create a block? No, it is not like that. The point is, if I want to create a block, imagine I'm a node. If I want to create a block, I need to do something to create that block. That doing something is called solving a particular puzzle. Okay, or else that is the concept called consensus algorithm. Similarly, imagine if there are 2-3 nodes who are trying to create the block. Now, which node will be able to do it, or which node you will, or which block you will consider? Okay, these are all the questions that need to be addressed. To do that, there is a concept called consensus process, in which essentially the nodes would be solving a puzzle. It is like this. All of you guys can do something, can mine the block or can create the block, provided you prove your ability, that you have the ability to solve that particular, to create the block. What is that ability? The ability means here in this case, it is like solving a puzzle. What is this puzzle? Okay, so the puzzle is like this. To add a new block to the blockchain, the participating nodes must come to a common agreement over time. However, sometimes temporary disagreement is also permitted. The method of agreement or the consensus must work even in the presence of malicious users attempting to disrupt. This is the another dimension. Now, let us see what is meant by that puzzle. A user gets the right to publish the next block only if their node or user, if they are able to solve a particular puzzle. Remember that particular puzzle is computationally intensive. Okay, number one. Number two, that solving of that puzzle is like you are having, showing a proof that you have done something to solve that, to publish that particular block. And that particular puzzle is designed in such a way that solving that puzzle is very difficult. Okay, that is what is you are trying to avoid or nullify malicious or people with notes with malicious intent to just like that publish the block. Okay, so how you do that? What is the puzzle? The puzzle is here. The puzzle is here. Use the SHA-256 algorithm. Why you are using SHA-256 algorithm? To create the hash. If you simply say this is my input, SHA algorithm will say that okay, this is the output. In a simple case, it will do like that. But puzzle is not that. The puzzle is you create a hash. You create a hash having some condition. What is the condition? I need a hash value of my blockchain or my block or my transactions. My hash, whatever the hash should be having first 5 digits or 5 zeros. Okay, that is the one condition. Okay, that is the puzzle. How can I do that, or how can I get it? If suppose, what is typically SHA algorithm will do, or a hashing algorithm will do? Hashing algorithm will take any length input and produces some output. After all, what you need, you only need a hash. But the puzzle is here. I need a hash, but the hash should have first 5 digits, all 5 zeros. How I can get it? You can get it provided you identify a random number. The random number is called nonce. So you identify that random number, which if you add it to your plain text or your block or your set of transactions, combining them and applying a hash would give you a hash value with which you are able to get first 5 digits as zeros. So how to identify that nonce? Where is this nonce? What is the computational algorithm? So identifying such type of nonces is, it's not simple. It is not very easy. It is not just like that you can do. Means what? I have a set of transactions. I want to create a block. When I want to create the block, I need to have a hash value. Now, it's not that whatever the hash value you give, I will take. I need to find a hash value. The hash value should have first 5 digits as 5 zeros or 5 ones or some combinations. But when I will get it, you will be getting it only if you identify some number. If you add that number to your transactions or the set of transactions and create the hash, you will be able to get that. But how to identify such a number? You have to do some kind of a computations. So now those nodes who are legal or who are legitimate only will do that particular work. It is called proof of work. So those nodes who solve this puzzle, means it is like a race. Who identifies this number first, they will I publish their block first. Okay, so this is called consensus algorithm. One type of algorithm is called proof of work. So it is not that I simply take any block published by anybody. I take a block who solves this particular puzzle, and they only can publish the work. So who solves the puzzle is called proof of work. Only those nodes blocks will be considered. That is called consensus algorithm. Similarly, there are other algorithms, and it is not possible simply, if you see here the previous case, to solve that particular puzzle in a brute force manner, you see the number of guesses that are needed. Okay, it's almost about 1,07,30,897 guesses. Okay, it's very difficult. It's very difficult. Okay, so there is no shortcut. Another thing is there is no shortcut, and they have to solve it. Okay, and once a user has performed this work and solved that particular puzzle, they broadcast that their solution and the block. So all other nodes will verify, yes, this fellow has done this work, and the block that what they created is a valid block, and then they consider that particular block and then add to their network. That's how your block publication or block adding to the chain would happen. How many there are so many types of algorithms. If you see here, proof of work, proof of stake, then your proof of weight, proof of burn, proof of capacity, proof of importance, proof of activity, like this. There are so many algorithms of consensus algorithms. Okay, and then, as I have already said, you will be finding certain conflicts that are arising when you are maintaining the ledger. So it may happen that multiple blocks will be published. So means what? One particular node takes a set of transactions and do kind of what I say proof of work and then publish. Another node may take another set of transactions and publish it. And sometimes another node may be doing it. So when multiple nodes are working, you will be having conflicts arising it. Okay, this is a typical scheduling problem. So this will create a different versions of the chains. So how to adjust to this conflict, solve that conflicts, and come to the resolutions? There are algorithms for that which will solve the ledger conflicts, so that first of all, conflicts are usually quickly resolved and all the nodes in the network have the same chain. Okay, it's not that different chains in all the different nodes. Okay, so that is called ledger conflict, and then they will try to resolve that. Okay, and obviously the longer the chain which is there, that would be considered. Okay, and another thing, not only so far whatever we discussed is the blockchain. It's only a database, it's only a record. But imagine if we add a piece of executable code on top of the chain, you call it as a smart contract. What do you mean by contract? When a condition is met, you do this. Okay, or else look, okay, this particular condition is satisfied, now execute this. That's what is contract. Okay, you pay money to me, I will give you this. Okay, or else look, this particular transaction has happened and hence do this particular entity. So this is what is the contract. So a smart contract is a collection of code and data. So far we have viewed blockchain as a database. Next, you are viewing it as a smart contract. What we mean by that? Imagine there are certain transactions happened. If you say do this particular thing, how you can say that? By writing a code. You call that as a smart contract. Okay, so you are having smart contracts that are happening. Then essentially you can divide the blockchain into two categories. One is called permission blockchain, another one is called permissionless blockchain. Okay, what do you mean by permission blockchain? It is like your local area network, wherein which you are in an environment wherein which you are trusting the other nodes. Essentially, what is a permissionless network? It is like your internet, wherein which you are connected to the different nodes, but essentially you don't know, you are not trusted. So permission blockchain, and imagine you are having a blockchain in our local area network which is called a permission blockchain network. Imagine your nodes are connected through a kind of internet which is trustworthy less or not trustworthy, then it's called permissionless. Accordingly, your consensus algorithms vary. accordingly your blockchain structures, the things what you do would vary. And of course, not only that, there are some consortium based blockchains. Okay, and remember, the kind of algorithms what you use, the kind of structures what you use, the kind of protocols what you use would vary. Okay, so if you see there are so many platforms in the industry which has taken Ethereum, Fabric, Corda, Ripple, Quorum, Swatooth, like this. There are so many algorithms, sorry, so many industry-based platforms are available. What I suggest you guys is to look at these platforms and at least get familiarity with the some of the industry platforms. Like, take an example, Hyperledger. IBM has their own blockchain platform, and if you observe here, in which industry it is applied, and ledger type, whether it is permission, permissionless, and all that. What is the type of consensus algorithm that is used? Whether the smart contract facility is possible or not. Similarly, governance. Okay, who is actually governing this particular blockchain? Okay, of course, though there is no central authority who owns this one, but who is actually governing this particular this thing? And the kind of providers. This is somewhat a little year back slide. You will be finding that much more updated these things in the internet. But the point is that those students who are interested to enter into this technology, use this technology, please, I suggest to try with the platforms. And if you see here, what are the skills that are needed and what are the job roles? Business leaders, blockchain professionals, blockchain marketing professionals, blockchain solution architects, blockchain developers, blockchain data scientists, administrators, security professionals. There are so many roles, job roles that are this one. And if you are, you just have a look at this particular, the information from this blockchain training academy, which is having this particular slide, which says, I'm very technical, then how to go about it. Imagine I'm not technical, how to go about it. Okay, wonderful the image that is shown here. Okay, and then there are so many references with which you can learn blockchain, the industry platforms and all that. So essentially, you need to do two things. Any technology, for that matter, whether it is a blockchain technology or any upcoming technology, if you try to look into the literature, you will find two types of literature. One is the literature coming from industry, which will be giving you focus only in the industry perspective. They don't talk much of the algorithmic aspects. Okay, they give only on the platform specific and all that. And on the other side, when you look at the literature from the research specific, like coming from the academia, they will be oriented towards the algorithms. They will be oriented towards the theoretical aspects. You need to have both. Okay, you need to understand both. Now, if you don't understand the consensus algorithms, and obviously you will not be able to follow the industry platforms. Similarly, if you don't know industry platforms, how actually these algorithms are adopted and worked and when they are adopted, even if you know simple algorithms, you cannot do anything. So have a right approach of balanced approach of searching for the literature in both industry and as well as academic literature. Okay, having a university, I think you guys would be certainly having access to both. Okay, through your digital library, and you have experienced faculty like your faculty members. So please utilize your faculty resources, digital resources what you have, and I'm sure that you'll be able to understand. But at the end of the day, if you observe closely, what is the backbone to the entire process? The core computer science. When you look at the data structures, you are seeing the data structures lying there in the form of Merkle tree, binary tree, and all that. And when you look at on the database side, you are able to see the databases and distributed databases. If you read distributed databases, some of the conflicts and all that you will be finding, scheduling and all that you will be finding there. Okay, updating and all that, how that happens. So fundamental problems in the distributed computing. Similarly, when you look at the networking aspect, Again, your network is there. When the network is connected, the security aspects are there. Means blockchain technology is essentially is an amalgamation of all your core computer science concepts, your databases, your data structures, your networks, your security, and all that. Okay, and of course, added to that, there is a business angle. Okay, so, and the use cases, there are n number of use cases. There are n number of use cases where in which you essentially wants to store the data, and you want us to store the data as number one in such a way that it is easily accessible, it is easily verifiable, and it is a tamper proof. Okay, so in all those things you can apply blockchain. And added to that, yes, when there are transactions added, can I do some kind of a contract execution over that? Yes, if this particular condition is met, can I execute this? Okay, so that's a smart contract. So these things are this one. Okay, and I think I'm at the end of the session. Thank you very much for all our patients listening, and please keep posting your questions here. I will be happy to address the questions. Madam, can you please post the feedback form?
Okay, sir. Right now I'll post, sir.
Yeah. So if you guys are having any query, please post in these questions. I'll be happy to address. So please keep asking questions. The last question I'm seeing is the Arvind one, which I have already answered. So please ask questions. Again, this is only 5 questions in the feedback, but except one question is having a descriptive which you need to give suggestion about anything you would like to add. But otherwise, they're all this one. Any queries?
Students are busy.
Yeah, you guys are in filling the form. Yeah, I understand.
I see. One more question. Like Bitcoin mining. Someone has raised the question. Bitcoin mining. Apart from that, I'll ask one question from my point of view. Recently, we all have heard that from Twitter accounts, some kind of intrusion was happening, and then the bitcoins have been stolen using the, accounts of famous people. So, what is your view about that, sir, and how it has been happened? Because we all are believing that Bitcoin is safe, but even then, within 2 hours, the intruders they were able to collect more than 1.5 billions of dollars of amount. So what do you say about it?
Yes. See, essentially, when you are using the Bitcoin or any kind of a cryptocurrency, madam, what happens is, as I have mentioned, you are actually using a digital wallet. What is the digital wallet? It is like, it's not like our account, wherein which if suppose somebody asks, what's your account number, generally for any kind of, imagine I want to transfer money to your account, I will ask, madam, what is your account number? You will give me your account number, and which your bank will be able to know, your authorities will be able to know. But in the case of digital wallet, what happen is essentially all these cryptocurrencies uses different types of digital wallets. You can think of digital wallet is like your your phone pay, or your UPay and all this, not UPay, what is a your Google Pay and all that. So what happens there is every wallet will be having two types of keys, like it uses your asymmetric key concept, wherein which one key which is private, and you keep one key that is called public. So if suppose I asked you to share, madam, what is your digital wallet number? I want to send your account, send money to your account. So your public key. So I will send money to your account through that, and you will be able to make some transactions over it, or you will be able to log in and you will be able to make it because you are having the private key. Since this digital wallets uses the public key pair, the government agencies, what they are not able to follow it up is, you can always keep changing your wallet key pair, like your asymmetric key technology. So the wallet is there, but you can recompute the key pairs at any time. That means if now you are sharing with me your public key, later if I want to send some more money to you, you will be giving a different public key because you recomputed your keys. So that is the reason why governments are not able to understand about or the authorities are not able to follow up with, because the frequent change in the key wallets, digital wallets. That is first thing. The second thing, since the underlying asymmetric key technologies, people can hack them. Means what? If I know your public key, if I'm able to get your private key, that is possible. The attacks on the public key technologies are already there. So the attackers, if they are able to attack your public key technology, they will be able to break your digital wallet also. If I knowing your public key, if I'm able to get your private key, means I have access to your digital wallet. That's how it happens, madam.
Okay, sir. Thank you, sir. Thank you, sir.
So it is true that no new bitcoins will be generated after. Yeah, the reason is, it is like this. It's about one person has asked about the new coins generation. Okay, so it is about this making this the efforts. Okay, how many coins can be minted per day? That is about that. Okay, so it is based on that. And member of ACM chapter means, whether you are a member of a particular, you are having a professional chapter in your institute. I am the member of that, so it's a member of that.
No, we provided that option in the feedback. So students, if you are a member, you click yes. Otherwise, you just enter no. Ranjini?
I think there are just.
I replied in the private chat, ma'am. I have replied to everyone.
Okay. I think there are no more questions from the student side. So,
Yes,
I
ma'am.
request all the students to please participate in the feedback. I'm seeing only 10 responses.
they will be, sir. They will be filling. They are filling a feedback form, so they will be filling. We are also getting a feedback form for a certificate generation. We will be sharing our feedback also, sir.
Definitely, madam. Definitely. Say.
Okay. Thank you, sir.
Thank you, madam.
Ranjini,
Shall I close, ma'am? Yes, ma'am.
Please.
formal vote of thanks, sir.
Yes, ma'am. Yes, ma'am.
Yeah.
Hope all the participants are taught with good content of blockchain technology. In case if you have any queries, please do post it on the chat box. Now I take the privilege to propose the vote of thanks. Thank you so much, sir. With great gratitude, the ACM of Kalasalingam Academy of Research and Education is thanking you. I believe that through this webinar, all the participants are educated with valuable information on blockchain technology. Thank you so much for spending your time with us. It is seriously so worth listening to your session, sir. We do expect your similar support in future for our students. I'd also like to thank our management, dean, students, coordinators participants for their enormous support. Thank you, one and all. Thank you. Thank you, sir.
Thank you very much, madam. At the outset, I would like to thank all the organizing team. You have done a wonderful job, even in the pandemic time. Classes are started, madam.
Not, sir. We'll be starting by
Okay.
17th.
So it's good that even without classes, students are able to join. That shows the interest of the students. And also, my apologies to Deepa madam. Earlier, I have asked her to change the schedule because of this. Initially we planned for first, and I've requested madam to change to third.
Yes, sir.
She published the invitation and all that.
Yes, sir. Yes.
We have this Smart India hackathon, which was launched. I was made as a jury in that, and
Okay.
that day we were totally occupied. And
Yes,
that
sir. Yes, sir.
information I have received about 10 days back, and
Okay.
that made to disrupt this particular date from postponed to from first to third. I'm sorry for that. Certainly, we will stay connected, and then we will contribute to interact. Thank you.
Sure, sir. Thank you so much, sir. Thank you so much. Ma'am, shall we wait for 5 more minutes? Let the participant
We will
complete.
wait. We will wait. Ashwani Kumar sir, thank you so much. You have spent your valuable time to our students. Postponing the event, it is not a big issue since we all are attending the event in online only. Thing is like the departments are organizing the events, the clubs are organizing the events.
Yes, madam.
More webinars. In fact, every student I can say almost they are attending one or two webinars for sure. That is ensured. So startup seminars are there, and then symposium seminars are there. So many events are there. So last minute I could somehow find the time in inserting this schedule today. And it's a great privilege for us also sir, to have you as a resource person as part of this Asian Distinguished Speaker Program. Hope we will meet again in the future for more number of events, sir. Thank you, sir.
Certainly, madam. Thank you.
Thank you, sir. Thank you, sir.